Look at this image. It's an astronaut riding a unicycle on Mars while eating a slice of deep dish pizza. It took an AI exactly 3 seconds to create this. But here's the terrifying part. 5 seconds before I typed this prompt, this image didn't even exist. Not in a database, not on Google, not hidden in some dusty server room in Utah. The AI didn't copy and paste this. It made it out of literal nothing. Which sounds like magic, or witchcraft. If we showed this to Gary, our resident 14th century peasant whom we keep in the writer's room for vibe checks, he would try to burn my laptop at the stake. But it's not magic. It's actually a brilliant, slightly chaotic game of digital hot potato involving pure static, mathematical guesswork, and a computer that has looked at more pictures of cats than any human alive. Today, we're going to reverse engineer the brain of an AI image generator. And by the end of this video, you will understand exactly how a machine turns a blank screen into a masterpiece. Before we talk about how it does work, we have to talk about how everyone thinks it works. When most people see an AI image, they think the computer is just running a glorified Google image search. They think it takes a background from one photo, the astronaut from another, the pizza from a Domino's ad, blends them all together, and then hides the seams. If that's what you think, congratulations! You are entirely wrong. If the AI worked that way, the file size of the AI program would have to be larger than the entire internet itself. You'd need a hard drive the size of a small moon just to store the source images.
That's no moon.
Instead, the entire brain of a modern AI image generator can fit on a standard consumer laptop. Step 1. You have to feed the beast. Before an AI can make a picture, you have to feed it. And not like a normal pet. You feed it like a competitive eater on the worst day of his life. Except instead of 40 hot dogs, it's basically every image that has ever existed on the internet. Billions of pictures. And here's the key part. Every single picture comes stapled to a little text caption. Dog, sunset, man crying in a 1994 Honda Accord. That is oddly specific, but okay. So the AI sits there for the digital equivalent of 1,000 years, just staring at it. Picture and word, picture and word, picture and word. Now here's the part that breaks people's brains. The AI does not actually know what a dog is. It has never pet one. It has no idea they're warm. It just notices that whenever the word dog shows up, a certain smear of fuzzy brown blobby pixels tend to show up too. That's the entire relationship. It learned the vibe of a dog. It's kind of like if you asked Gary here to draw a dragon. Gary has never seen a real dragon, because they don't exist. And also, side note, Gary has scurvy, but Gary knows the concept of a dragon. Scales, fire, wings. Good job, buddy. Now go eat that raw turnip I gave you. Yeah. So now this thing has memorized the statistical flavor of essentially all human visual culture. The Mona Lisa, your cousin's wedding, 11,000 pictures of cats in tiny hats. And you think, cool, it has a giant photo album. Just copy one. But that's not making anything new. So how does this machine make a picture of something that has never existed? Step 2. Now that the AI understands concepts, how does it actually build the image? It uses a process called diffusion. And to understand diffusion, we first have to talk about murder. Image murder, that is.
There is a third option. It involves murder.
To learn how to build an image, the AI first learns how to absolutely destroy one. Watch. We take a real, normal, perfectly innocent photo, let's say this cat, and we add the tiniest bit of static to it, a little TV snow, then a little more, then more, then more. We keep going until this cat is completely, totally gone, and all that is left is pure random snow. This is called forward diffusion. The computer deliberately destroys the image until there is absolutely zero recognizable information left. It is pure, unadulterated noise. You look at this and see a broken television. But during training, the AI was watching this destruction happen in reverse. It was forced to look at step 99 of the static and guess what step 98 would look like. It did this over and over, learning how to scrape away microscopic layers of noise to reveal the structure underneath. Think of it like a master sculptor looking at a block of marble. The sculptor doesn't see a rock, they see the statue hidden inside, and they just chip away the pieces that don't belong. Except in this case, the block of marble is a chaotic soup of random pixels, and the sculptor is a very high-powered graphics card. If you give the AI pure static and tell it nothing, it will just wander around in the dark. But you give it a prompt, you're giving the sculptor a blueprint. Step 3. the move. Here's the core problem. Computers speak in numbers. Humans speak in words and vibes. When you type a dramatic portrait of a cyberpunk cat, the computer doesn't naturally know what cyberpunk feels like. It needs a translator. Enter CLIP. Contrastive Language Image Pre-Training. We'll just call it CLIP. This is the bridge between the world of words and the world of pixels. CLIP's entire job is to take your text prompt and turn it into a mathematical vector, a coordinate, in the massive multi-dimensional map of human language. In this mathematical neighborhood, cyberpunk lives right next door to neon lights, and just across the street from futuristic. Way over on the other side of the map, in the dark zone, lives Gary. Hey Gary! When you type your prompt, CLIP takes those coordinates and hands them over to the image generator. It says, hey, look at this pile of random static. I need you to guide the reverse diffusion process toward the cyberpunk cat neighborhood. If you see any pixels that look like they could turn into a neon light, keep them. If you see pixels that look like they're turning into a medieval turnip, destroy them immediately. So let's watch the magic trick happen in real time. This is exactly what happens inside the machine over the course of those 3 seconds. First, the AI generates a grid of completely random noise. It is pure luck and chaos. No two starting grids are ever exactly the same. The AI applies your prompt blueprint. It looks at the random noise and says, hey, those 3 gray pixels right there, if I squint, they kind of look like the silhouette of cat's ear. It lightly alters those pixels to make them look slightly more like an ear. Next, the AI repeats this loop. It evaluates its own work, checks it against the clipped prompt coordinates, removes more noise, and sharpens the edges. The blobs become lines. The lines become textures. The final pass. The AI cleans up the micro details. It adds the reflections in the goggles, the individual strands of fur catching the neon glow, and finalizes the contrast. Out of the absolute chaotic nothingness, a highly specific, perfectly structured image has emerged. It didn't copy it. It hallucinated it into existence using nothing but probability, math, and a guiding hand. Remember step 2, where we train the AI slowly, destroying a real photo step by step into pure static? Making a new image is the exact same process, just run completely backwards. Training is real picture, add snow, add snow, add snow, until there is nothing. Generating is nothing, remove snow, remove snow, remove snow, until there is a picture. The AI never actually learned how to paint. It learned how to undestroy. It creates brand new things by studying the exact way images fall apart, and then pressing rewind so hard that something new falls together. It got so unbelievably good at watching reality crumble into dust that it figured out how to run the dust in reverse and pull pictures out of the rubble that never existed in the first place. We are living in the moment where the line between what is real and what is mathematically conjured is vanishing entirely. The next time you see an impossible image online, remember, you aren't looking at a collage. You are looking at the machine that learned how to see the world, broke it down into dust, and figured out how to build it back from scratch. Okay, that lesson's gonna cost you 1 subscribe. I'm just gonna flip this little screen around here, and yeah, you can tip me whatever you feel like. But seriously, hit the button. Gary needs money for modern medicine. Gotta get rid of that scurvy.